In this video, I'll be creating the framework for a modular design, as well as building the first module that will control the intensity and the color of the moonlight. So let's get started. The first thing I'm going to create is a C# class that all the modules can inherit from. So I'll create a new script, and I'm going to call it dInModuleBase. I want to do more than just create a base class. I also want to create an abstract class that will require the implementation of a function. If you've never created an abstract class, they can be quite helpful. They also have some similarities to interfaces. Or at least that's how I think about it. An interface allows a developer to require certain functions in any class that implements that interface. A class can implement multiple interfaces, so they can be very useful for building up functionality. However, the interface doesn't allow variables to be defined or for functions to be written out and inherited. An abstract class, on the other hand, will allow variables and functions to be fully defined, as well as requiring certain functions to be implemented in the new class. It's also worth noting that a class can only inherit from one other class, so choosing between an interface and an abstract class does take some planning. For what I'm doing, either could be used, but the abstract class seems to fit best in my opinion. We need to add the keyword abstract between public and class. This will also allow us to label functions as abstract further down in our code. Next, I'm going to add a protected reference to the day-night cycle script and call it day-night control. The keyword protected allows the variable to be inherited but otherwise be private. I'll add an onEnable function. In this function, the script will get a reference to the day-night cycle script. Since all the modules will be placed on the same game object as the day-night cycle, we can use the keyword this, which saves us from having to search the scene for the object with the script. Then comes the abstract function. I've called it updateModule and given it a parameter type of float and called intensity. We'll be passing in the intensity value from the day-night cycle script. An abstract function is defined more or less like a normal function, but with the keyword abstract. Also, there is no body to an abstract function, and the line ends in a semicolon. The function will be fleshed out in each of the classes that inherit from the script. And that is the usefulness of an abstract class. No longer do you need to remember to override, and there's no worries that the function won't be implemented. We need to make a few changes to the day-night cycle script to make use of the modules. The first change is to add a private list that will hold references to all the modules. Next, I'm going to add two public functions. The first is called addModule and takes in a parameter of type dInModuleBase. This function simply adds the input value to the module list. The second function is called removeModule. This function also has a parameter of type dInModuleBase. This function, as you can probably guess, removes the module from the list. These functions will allow each module to effectively register or unregister themselves from the day-night cycle. This keeps things tidy and means you don't have to remember to drag and drop in the inspector to assign modules to the day-night cycle script. To get the modules to register themselves, we need to add a few more lines to the module base code. In the onEnable function, we'll add a call to the new addModule function and send in a value of this. Next, I'll add an onDisable function. This function will call the removeModule function. In this case, I've added a check to make sure there is a valid reference to the day-night script. When you exit play mode, the scripts will disable, and the modules will likely not be able to find a reference to the day-night cycle script, as it will likely disable first. This is a very minor issue, but I like to avoid throwing errors even if it doesn't affect gameplay. Just in case, I've also added a check to the onEnable function. At this point, the modules can register and unregister themselves, but nothing else will happen. So we need to add some functionality to the day-night cycle script. The script needs to call the updateModule function on each of the modules. To do this, I'll create another private function called updateModules. In the function, I'm using a for each loop to iterate through the items in the module list and call the updateModule function on each of the modules. The intensity value also needs to get passed through to each of the modules. Lastly, the updateModules function needs to get called in the day-night cycle's update function, so the modules get updated each frame. The update function could also be replaced by a coroutine and maybe update once per second, or even less to save on CPU cycles and improve the performance of your game. Next, I'll start to build the first module. This module will control the moonlight, both its color and intensity. Before we get to scripting, let's add in a second directional light that will play the role of the moon. This new light needs to point in the opposite direction of the sun, which is not physically accurate, but does produce a reasonable result. In my scene, the sun is rotated on the x-axis by -90 degrees, so the moon needs to be rotated on the x-axis by +90 degrees. This gets the two lights pointing in opposite directions. The moon should also be a child of the daily rotation object so that it rotates at the same rate as the sun. By default, Shadows are turned off on the new directional light. I've chosen to enable soft shadows, but the choice is of course yours, and turning on shadows can hurt performance and frame rate. With the light set up, I'm going to create a new C# script and call it Moon Module. In Visual Studio, I'm going to delete the start and update functions as they won't get used. I'm also going to set the script to inherit from dn module base. Once I do this, you can see that there is an error. This is because I have not implemented the abstract update module function yet. You can type it in yourself, or you can right-click on the error and choose Quick Actions and Refactorings, then choose Implement Abstract Class. This will create the missing function automatically, and as an added bonus, avoid spelling errors. Before editing the function, I'm going to add in 3 variables. All 3 will be serialized and private. No other script needs to access the variables, but I want to be able to edit them in the inspector. The first variable is of type light and called moon. This will provide a reference to the directional light. The second is of type gradient and is called moon color. The last variable is of type float, and I called it base intensity. That's maybe not the best name, but I'm going to go with it. This variable is how much the intensity of the moonlight will change throughout the day. Finally, we get to the function. In the function, I want to adjust both the intensity and the color of the moon. I'll start with the color. When the sun is at its low point, that is when the moon will be at its high point, so they need to do opposite things. To do this, I set moon.color equal to the moon color gradient, evaluated at 1 minus the intensity. This has the value of playing the gradient backwards, or opposite of the sun. For the intensity, I don't get too fancy. I set moon.intensity equal to the quantity 1 minus intensity times the base intensity plus 0.05. This last value gives the moon's brightness a little boost. It does, however, mean that the moon will always be on, even during the day. But just like with the sun, this will get taken care of by the color gradient. Back into Unity, I've added the moon module script to the same object that has the day-night cycle script. Make sure to drag the moon directional light into the correct slot in the inspector. I set the base intensity to a value of 0.35. This is low, but prevents the night from being totally dark, which is a big reason to have the moon. The last thing I need to do is, of course, the color gradient. I set the color of the 0 position key to black to ensure that the moonlight is effectively off during the day. I've also inserted a new key and given it a bluish color. I've copied the same color to the key at the 1 or 100% position. Pushing play to test the script is clear to see that the moonlight intensity is changing as well as its color. Returning to the day-night cycle script and enabling debug mode, we can see the modules list. Toggling the moon module on and off, we can see it register and unregister from the list. Perfect, everything's working. With this module framework, it's now easy to quickly add new functionality to the day-night cycle. In future videos, I'll cover several modules that I've created for past projects. If you've enjoyed the video, give it a like and subscribe to the channel. If something can be improved or you have a question, leave a comment below. Also make sure to check out my Patreon page and Discord server. Links are in the video description below. In the next video, I'll set up a module that will control the colors of the procedural skybox. Thanks for joining, hope it was useful, and see you next time.